Okay, I am making a couple of videos to help with the kinematic problem. So hopefully some of you guys are on Canvas and can use this as a helpful resource and tool. I am going to read the questions. So I wrote down two different questions and we're just going to work these problems through. So for number one, a snail traveling 0.62 centimeters per second slows his pace to 0.4 centimeters per second in the span of 3.2 seconds. Find his acceleration. Remember that acceleration can be both positive and negative, meaning that you can have a positive acceleration with a positive velocity, which means the snail would be speeding up, or you could have a negative acceleration with a positive velocity, meaning he would be slowing down. In this case, I want you to start by reading the question and just thinking about it in your own head. So it's a snail, and it says the word slows, right? He's starting at a faster velocity than he's ending at, so we know that he's slowing down, which gives us a hint about our answer. We know our acceleration should be negative. It's also giving us a time that it takes him to slow down. So I'm going to underline all of my units. So 0.62 centimeters per second, 0.4 centimeters per second, and 3.2 seconds. I am now going to try and identify what each of these units are. Now, something you could do is check in your notes, right? We have a whole table of our units and what they mean. I know that centimeters per second or any sort of meters per second is either an initial velocity or a final velocity. Okay, so I can use that and I can use the context clues in the problem to figure out this is my initial and this is my final velocity. So my initial velocity, V naught, is 0.62. My V final is 0.4. I also have one additional detail. It takes him 3.2 seconds. That is a time. Time is always in seconds, 3.2. I'm looking for acceleration. This is the second biggest problem I'm seeing is people don't know which equation to choose. Now I'll write out, I'm going to write out the three kinematic equations up here. Oops, and I chose green, whatever. I'm just going to use green again. So I've got V final equals V initial plus AT. My second and favorite equation, X equals V naught T plus 1/2 AT squared. And my final equation, which is V final squared equals V initial squared plus 2AX. Now in this first equation, I can solve for final velocity or I could solve for time, but I can't solve for distance. It's not in this problem. For the second problem, I could solve for X or I could solve for T, but I can't solve for final velocity. It's not in this problem. For the last problem, I could solve for V final or I could solve for X, but I can't solve for T. It's just not there. So in this initial problem, let's see what we have. Well, we have a V final right here. We have a V naught and we have a T. I've got a V final, I've got a T, and I'm looking for an acceleration. It just makes sense to use the top equation. I don't have a distance, so I would not pick 2 or 3. That wouldn't make any sense. So I'm going to switch back colors. And hopefully this video uploads because it's going to be long. So I'm going to throw in, okay, I know my V final is going to be, I'll write the equation first. So V final equals V initial plus AT. Now I'm plugging in my V final is going to be 0.4. My V initial is going to be 0.62 plus A, which we don't know yet, plus T, which is 3.2. Sometimes you're going to want to switch the variable and the number just because it's easier to look at, but for this case, I'm not going to worry about it. Here's my second biggest pet peeve is I'm seeing people add these numbers together. We cannot add something with a variable on it, okay? That does not allow us algebraically to add these. So first I like to pretend this variable is like a stinky person at a party. Everybody's got to get away from him. So this 6.2 is going to get away. It's going to be subtracted because it's being added here. We know we have to do the inverse operation to bring this to the other side. So we're going to say minus 0.62 minus 0.62. Once we do that, we can subtract 0.4 and 0.62. You can use a calculator if you want to. You can do it in your head if you're good at that. But we know the answer is going to be negative 0.22 equals 3.2 times A. Now we have one final step. We have to divide. We got to divide by 3.2 on both sides. And we should be noticing we're getting a negative number here. And that is correct. When we divide, we're getting 0.069 meters per second squared. It makes sense that it's negative because he's slowing down. Slows. Hopefully you guys got that answer. I'm going to do another one now.